Hi, 6 years. Probably meant to get this up yesterday evening, but didn't get it up. It's going to be kind of a run through trigonometry from the very start, from looking at right angle triangles right through to what we looked at today, which should have been possibly area of a triangle, that question last night, and then we'll pop up some of the questions that we did. Not there, but here. Okay, so we'll take some of those questions we did from the book. So what I'll do is we'll go back here first of all, and we'll look at triangles in terms of right angle triangles. So what I told you was trigonometry is about the three-sided. Everything's in rules of three. So make this a bit bigger. Name the sides. First thing. So there's two situations which arise. We have a situation where you have a right angle triangle or a non-right angle triangle. So to begin with, we're talking about right angle triangles. Okay. So everything we're doing here, it revolves around right angle triangles. We just changed the color here slightly, so you know what I'm talking about. So in right angle triangles, as we have here, there are three sides. You must name the sides. The first thing you do is name the sides. To do that, you have to find the right angle. This is given to you. You go out from the right angle and you find the hypotenuse. So that's the hypotenuse. Then you need to establish what's the angle of the question. In this triangle, I have an x here. So therefore, this becomes the angle for the question. Go straight over here, and this becomes called the opposite. Okay, that's the opposite. So that's the opposite side of the angle of the question. And then this becomes the adjacent, the other third side. So that's how you name the sides. If I had made this angle the angle for the question, then straight across from here, this would have been the opposite, and this would have been the adjacent, opposite adjacent. But I didn't. The x here, okay, was the angle for the question. So the opposite adjacent can change depending on what angle the question is, okay? So for example, in this question here, it's very obvious to see what is the angle of the question. I need to make this print a little bit smaller here. So 32 was the angle for the question, therefore that's the opposite. Of course, this is the right angle, that's the hypotenuse, and that becomes the adjacent. Angle for the question is this one, that makes this the opposite. Right angle makes this the hypotenuse. If we look down here, in this triangle, to name the sides, here's the right angle, that makes this the hypotenuse, okay? So the hypotenuse is the side labelled S, in this case. Here's the angle for the question, therefore this is the opposite, so therefore R is the opposite. And side T then must be the adjacent, okay? Then we move along further and we started getting into questions, and I told you there was a process involved. This is a really useful process. It's kind of watertight, which avoids you making mistakes. So you name the sides. Here's a question in red. You name the sides. So the sides are, this is the right angle, therefore this is the hypotenuse. This is the angle for the question, therefore this is the opposite, and this is the remaining side, the adjacent. That 42 degrees there refers to this angle here. It's 42 degrees. So you write the rule, SOHCAHTOA, 9-letter word divided into three parts. SOH, S is equal to over H. CAH, C is equal to H. Tan is equal to opposite over adjacent. The next thing you write down is what do you have and what do you want. This is really important. People don't underestimate the importance of this. This allows you to pick out the correct rule. So when I see this here, I can see that we have the angle, it's 42 degrees, and we have the hypotenuse, it's 12 centimeters, and we're looking for the x is on the opposite. So the only rule that uses opposite, you see that dictates which sides are in play here. Hypotenuse and opposite in play, and that means we're using the sine rule. So the sine rule is the one we're going using. Okay, so with that in play then, we set up our equation. There are three spaces in our equation. The space over beside the angle, the sine or the cosine or the tan, the angle in this case is sine, and then we have the space above and the space below. We have to fill those three spaces. Remember, trigonometry, it's about three-sided shapes called triangles. Everything is in threes, so it's really important that we, that we name everything in threes. So there's three spaces here to be filled. So there's three spaces. We fill them. In this case, we do know the angle and we don't know the opposite. So the x, so I give you three scenarios here. So the x here ends up on the top. When the x or the unknown ends up on top, which is the case here, the number that's the denominator comes over here and we multiply it over, and that's how we get to this point here. We multiply that to the calculator and we get 8.03, I think, by calculator. Okay. Scenario number 2, we're given another triangle. In this case, the unknown is going to end up in the bottom. Okay, but let's go through the process again here, nice and carefully. So in the process, here's the triangle up here. Here's the right angle. That's how we name the hypotenuse. Here's the angle of the question that becomes the opposite, and this is the adjacent. You write the rule in its 3 parts. Write the rule. S is equal to over H, C is equal to F, T is equal to over A. What do we have? Well, we have the adjacent. It's 14.7 centimeters. We have the angle. So remember, don't write A and A here, it becomes confusing. A for adjacent, A for angle, and we have the hypotenuse. So there's only one rule here that involves adjacent hypotenuse, it's the cosine rule. So we write the equation, our equal sign goes here. The cosine, we pick the cosine as the rule, and we leave our space here, and we have 2 other spaces here. So we have our space here, and we need to put that space in, and we have our space here and our space here. And in this case, we have the angle, it's 27 degrees, that's why that's up there. So that's their angle down there. And we have our, we have our 4.7 on top, and we have x in the bottom. So in this case, in the last question, if we go back over here very quickly, the x was on the top. In this case, the unknown, or the x, is on the bottom. So how do we fix it out? We swap. We swap over the x over here, and the cosine 27 goes underneath the line. That's how we end up at x over here, and the cosine 27 underneath the line. You simply put all of this in the calculator, and this is how you get your answer. So that's scenario number 1, and this is scenario number 2. Let's go over to scenario number 3, and how that unfolds. Scenario number 3 is not completed here, so we're going to do it now in class. So we'll do it in, we'll pick it in blue. Just want to get it right here in terms of being able to see it. Okay. So we're given a triangle. We've named the sides. Right angle here, that's the hypotenuse. Here's the angle for the question, therefore that's the opposite, and here is the adjacent. SOHCAHTOA is written, SOHCAH, and T is equal to O over A. We write down what do we have and what do we want. Okay, so I can see that we have the opposite, we have an angle, and we want the hypotenuse. No, sorry, I'm wrong here. So we need to scribble this out. We don't have the angle, we have the adjacent. And we want the angle. So the question is find the angle. Okay, which rule involves opposite and adjacent? Of course, it's the tan rule, which is here. Set up our equation. The tan of, we'll talk about this in a second, is equal to something over something, opposite over adjacent, O over A. So let's then just make this a bit bigger for ourselves. We've decided the tan of x degrees, because we don't know that, is equal to opposite over adjacent, which is 2.7 over 7.3. So we'll write that in here, 2.7 over 7.3. So to finish it out, the fastest way to do it is go shift and tan. So I'll write it, shift, to get the inverse of tan, shift and tan, and put 2.7 over 7.3 in brackets. When I do that, I should get, and please check, if you can, please check to see if you get it. Shift and tan, and we open a set of brackets. And close the brackets, so I'm just doing here my calculator. The answer is equal to 20.297, which is 20.3 degrees. That's the answer. We moved on from that then today. So there's another example of that there. Okay, that question there. It's a sine rule. So we moved on to that today. We talk about, after that we talk about Pythagoras. The Pythagoras theorem is given here. So Pythagoras only works for right angle triangle. And in this case we have a Pythagoras rule here. So here's the right angle, that's the hypotenuse. And in Pythagoras we're not really worried about what is the opposite of the adjacent. It's not really important. All we have to do here is establish what's the hypotenuse. So then the equation becomes 12.7 to be squared, the square of the hypotenuse, is equal to 7.9 to be squared plus x to be squared. That's what we've done up here. Okay? And here. To finish it out then, x squared is equal to 12.7 to be squared minus, because that comes over, with minus 7.9 to be squared. And get the square root of your answer. you get x squared. Well, we get x squared is equal to 98.88. X squared is equal to 98.88. The square root of 98.88 is equal to x, and that works out at 9.94. Check that in your calculator. All right, that is it on the non-right angle, on the right angle triangles. So today and yesterday, then we also went on to non-right angle triangles. So I'll take that up in the next video. Okay, we'll talk about that in the next video. Thank you.